Let's see if it works or not. Let's see. Select stream, upcoming. Should not be upcoming. It's excellent. Yes. Let's see. Notification isn't out yet. Oh well. Yeah. I probably should export my thing. Yes. No. It's this. No, not this. This. Not control escape, control thing. Conda freeze? What was that? Pip freeze? No, Conda. It's a Conda. Hmm? Good. Forgot how to do. Conda export quad. Requirements 60. It's output. Okay. Okay, that's just it. Fair enough. Markdown cheat sheet. Cheat sheet. With the lists, it's just okay. It's just one. Okay, sure. This. Statistical model, logistic regression. Statistical model, logistic regression. Not this. I need a folder. Yeah, statistical model. Yeah. Model.py. Need to ski kits learn. Machine learning and yep, okay. Install. Windows Conda. Conda Forge. SQLearn. Okay. Conda install. Ski kits. Learn. Shadow Conda Forge. There. Think this should work. Okay. I felt like that was getting a hiccup there. Package not found in current channel. Oh, I see. Kid's not kin. Yes. Excuse me. Let's see. There we go. Lasso. No multicast. List. Linear models. Yeah. Ordering, rich regression, and classification. Logistic regression. Ah, damn. Rich regression. Rich regression addresses some from ordinary least square by proposing penalty size of coefficients. Personalized reducing squares. Alpha stats fit coefficients. From scalar, not scalar. Scalar. Import linear model. Class. Do I want rich classification? Rich regressor as classifier. This classifier first converts binary targets to 1 and treats the problem as a regression task when the same objectives above. Can be faster than sufficient high number of classes because it can compute project matrix. Ooh, nice. Okay, I guess I'll use rich classifier. Yeah, I can later do logistic regression, I guess. Rich. Then again, I can do both at X, but oh well. Rich classifier. Def minutes has here. Yep. Okay, how does this work? Alpha regulation strike must be such flow to improve this condition. Okay. Whether to calculate the sets for small set false, copy bool, max iter, class weight. Should inform class label weight. If not given, all classes have weight 1. The balance mode uses okay, that's fine. Based on the type of data. The fuck? The first goddamn. Okay. The first goddamn thing that comes up is load breast cancer, return XY true. Oh god. XY. Okay. Score XY. A confidence score for samples. Decision function fit. And the array scores eventually n samples, n features, n samples. Okay, fair enough. Yeah. Self dots classifier. I'm just gonna linear model dots rich classifier. Features. Okay, yeah, fair enough. Target weights. Given a float, the restaurant will be the same weight. Alright, let's see. And splash notes and samples and features. So yeah, it's individual. How can I? Okay, I think maybe this is the fastest. Maybe. No. Fuck it. I'm just gonna be. I'm gonna do that later. Probably. We're missing the library sub. Okay. Oh, okay. Skipping the SS skip. My pun. It's installed the missing library stubs or PyType marker. Alright. Def fit. Well, this is gonna be the board, which is gonna be it wants an ND array, so I'm gonna guess it's from NumPy, I guess. None. Self dots classifier. Dot fit. And these from type import type check. No, it's type checking. If type checking import from numpy import and the array. Board and the array, and then prediction, no, truth. We grounds truth. It's in the array. Board and ground truth. Yeah. Research class, no. Floats. Creation of the solver, quotient torch, specify different conversion criteria. Alpha fit intercepts, whether calculates the intercept model, sets nodes would be used. Centered, no. If true X would be copied, else it may be overwritten. Max centered, maximum number of iterations for gradient solver. Okay. Guess, well, we'll just do. alpha. And max enter and tool. Max duration would be none. And tool. 1e minus 4. Huh. Iterations. And tool. Yeah, there we go. So ground truth. Yep. And then it still need all the thing they need. It would need is just prediction, I guess. Turn the mean accuracy given the test set and labels. Nah, no test sets. Def predicts the self and the board and the array. And this would need to be just an integer, I guess. But oh yeah, that's wrong. And the array. Well, the thing is, I'm just gonna pass the board to it, which is just gonna be and numpy, that is that, so numpy change matrix stacking and classes and feature. No. Fits. Sparses and samples, which means the amount of samples and features. Oh, wait. Okay, that's not of n samples. Wait, samples for y? Huh? Okay. Interesting. And the array of the amount of samples, so that's the samples, yeah, which means every single thing, and then just samples. Wait. Yeah, then I'm under the wrong impression then. I guess, do I just need to initiate multiple? Skikid multi-class classification. Multi-class classification. Multi-outputs. One versus the rest. 1v1 output code. Number of targets. Value multi-class indicate multi-outputs. 2. 1v1. Multi-class has 1v the rest. Support multi-label. Multi-class classification. Wait, what's that? Multi-class and multi. Okay. Multi-class classification. All classifiers in Schema do multi-class testing out of the box. You don't need to use a Schema multi-class module unless you want to experiment with different multi-class strategies. This is one of the specifications, for example. Wait, then how do you do it then? So if all of them support multi-class, so this alpha fits copy max iter class weight. Weight associated with classes and form class label and that. Yeah. But how do I guarantee multiple classes? Skikit learn sets up multi-class classification. Most class using skikit learn. Yep. Trains test splits. SVM. Let's split them a train decision tree, training sets. Use the buffer to take tables of test data. That's not what I want. Eve Bayesian. What? None of them really do anything. Yeah. Okay, then what it would be is then I guess I can just like a list of four classifiers for each direction, because I don't see where you can't for most classifiers. N class classifiers are trained in one versatile approach implemented by taking advantage of multivariance and cross validation. Wait, what? Okay, but where do you indicate how many classes you have and want? Because the Y is just an N sample, which means the sample weight. Float or NDU shape the sample. Default not. Individual weights for each sample. Well, every sample will have the same weights. No. What? Where? Wait, what? Skikit learn make multi-class classifier with rich classifier. Classifier working for multi not clear. Yeah. Yeah, effects. Actually wants to do multi rather than binary. Random. That is 5 samples. 4. That's yeah. From a schema. Binary. Fits to Y. New rich classifier. Oh wait, does it just gives you what? Wait, what? So you wait, what? So you just do you just give it what you want? I guess. Hmm. Wait. So the why you give it, is it just the index of the class? Returns empty array of shape. A matrix containing the predictions. In binary and multi-class problems, this vector contains n samples in multi and it returns n samples, n samples and outputs. Why? How is this more complicated than goddamn neural networks? Yeah, let's just question. This is by defaults. With class problem only lead sag and manual multi-nominal loss, but sure. Penalty default is L2, which is good. Do toll plus weight. Max iter and feature number of features seen during fit. Feature name in the array classes, list of class tables, class swarm start multi-class auto shows this over a binary problem fits each table for a multi-nodal loss, minimizes multi-nodal loss across entire probability. Solver random. What the fuck is this implementation? To be very much honest, I have only really worked with scikit-learn for like not long. I thought it would be easy. But no. The fuck? You know what? Fuck it. It's got that. Requirements, your requirements update. Sure. Commit a push. Okay, sure. Let's do Python. Fuck it, let's just go straight to fucking AI. Let's go straight to fucking neural networks. And then RNNs. Okay. CUDA, Conda. It's not available. And CPU. Pip3. Within the thing. Oh, already have that installed? Requirements. Pip, pillow, PyTorch, Torch Vision. Okay, yeah, Torch is installed. Neural networks. Delete this here. Not this. I need the folder, which is gonna be RNN model.py from Torch. let's get the documentation. PyTorch recipes, tutorials. Nice, it's always good. Attention. CUDA. Where the fuck is he? Okay, I think PyTorch. Rn. PyTorch dots and then torch dot and then dot rn. Input size, hidden size, number of layers. Nonlinearity is 10. From import and then class and then dots module I need to do PyTorch simple neural network example. There you go. There's this new network and then dot module. Yep. Okay. That is right. Def init. Super init keyword arguments. Yep. Self dots layers. Is equal to nn dot sequential. That'll be nn dots. I guess it could be linear first, but I would need to have system int there. Okay, so that would be the size of what I want. Expand that. Yeah. Okay, I guess I can do that. Self. No. It would be size times 2 and then that's, I guess, expand it would be the best. Calculator 28 times 28. Oh, it's a, that's okay. Okay, maybe it's not the best. It's just on and then apply a multi-layer, I don't know, with 10 or Rayleigh nonlinearity. Just input hidden size number of features in the hidden states H. And then, yeah, okay. I think the best would be then, I guess, go through an RNN first? No. Maybe it's best just to do a best through a linear first that goes through it and somehow and gets an different so that I can draw a different representation, maybe that, and then dots this size 2, and this can Let's no. Size. Oh wait, how many in the hidden states? That's what it is. Well, if it's in hidden states, that's times 4, I guess. And then what's the last one? 2. Number of layers. Number for current layers. Would mean stacking 2 items together for stacked with second item taken. Put first in a computing in front of results. Default is 1. Default bidirectional. Okay. RNN is output and HN. Okay, that's. Let's make a very simple thing. It's just gonna be 2. Self dots first. So that will interprets the input. Then self dots RNN is gonna be the RNN layer. RNN layer amounts, which is going to be an int. That's going to be a default 3 because fuck it, I just feel like doing 3. So H0 needs to be that. Okay. That's 2 unround of 2 to PyTorch rand. The random function would be sequence of integers reflecting the shape of the output tensor. Okay, so it's some 2 by 3 by 20 tensor. But why is that? Because it's some 2 by 3 by 2. Why is it 2 by 3 by 2? Why is that as hidden layer like that? Tensor of shape D times number of layers and H out. Or that's batch size, I see. Yeah, not gonna do batch size. So D times number of layers. D is 2 if bidirectional true. 2 if bidirectional equals true, otherwise it's 1. I'm gonna guess I didn't turn on bidirectional. Bidirectional false. Why not bidirectional? Fuck it. Bidirectional is equal true. Fuck it. Self. What's hidden? Hidden states equals. I would need torch from Random. No. It's ones. No. Zero? No, once is probably better. No. Zeros, which is just gonna take a sequence of, yeah. Do I need to put them in a tuple to make that? I forgot. No. So what I need here is d times number of things, which means 2 times number of layers, which is number of layer amounts, times h out. H out is hidden size, and hidden size right now is size times 4. Yes. So we have the first layer, then we have that, and then let's say fuck it and put it. And then let's put some things out there. Out is h out. Output and hn, which is L times for unbatched outputs, which is L sequence length times 2 times h outs. Hidden sensors is that, yeah. L times sequence length. Wait, sequence length. It's a 5 to 10. L is sequence length? Sequence length. Input is L times H in. H in is input size. On an example, NLP classifier names networks in RNF and forward. Yes, okay. Input size, hidden size, output size, hidden size. And then out, that's the output, yeah. Hidden size, output size, 0. That's X is the input. FC is that out. Out is the size. Hidden size. Hidden size is then that. Okay, yeah, sure. Which input size, which is hidden size, I guess. Output. sequence length is then just L. I guess it would just be 2 times h out is hidden size. Yes. Yes. Okay. Self.lin. Oh, not self. And then dots linear of 2 times hidden size. Hidden size, which is times 4. Then this will go for size times that'll be size 2/8. Let's do that. No, and dots Rayleigh. Wait, what? Rayleigh's not in here? It should be. Oh wait, it's because I did. And then dots Rayleigh 6? No. Why is Rayleigh 6? Module added to. What's the difference between Rayleigh 6 and normal Rayleigh? PyTorch Rayleigh 6. What's that? Applies the Rayleigh 6 function element-wise. Guess they're just different type of Rayleigh, I guess. And then dots linear of size times 4 size times 2. And then dots Rayleigh. And then dots linear of size I think, no, 2 here. That goes into a 4. Yeah. And then our self dots sm is equal to nn dots softmax. That will give a softmax of softmax mid module for me to use. Yes. Okay, and then I'll do def forward, slow forward. Why am I not getting the usual forward? Def and then module. Yeah, why am I not getting forward? Okay, so sure, self. And then this is going to be the board. It's just going to be an int. This will be then the board will go into x1 is gonna be first layer of board. Let's think. Wait, I just thought that doesn't work because if I that doesn't wait. No, it would work. I no because hidden states. Hmm. Hidden states. Because if I do that, because here I have hidden states. Hidden states, that would mean um I don't know.